Sir, I don't have permission to share my screen. Can you please make me host?
Yes, sir. Now you try.
Okay. Welcome back, participants. So I believe that before my session, you had a session on SQL, right? MySQL. So have you seen that how to create a table in a database? So whenever you have application in a software industry, suppose you're working on some project, right? So maybe you will have a web application, mobile application, it could be any type of application. So let's say this is your application, right? And through this application, end users will interact with this application, and you may generate some data in those transactions. And okay, yeah, and then you will save whatever data is being generated. You are going to save that data in your DBMS in the form of tables. For example, if you have built software application for let's say employee management, then employee related information will be stored in this DBMS. If the application is related to college management system, in information related to faculties, students, projects, courses, subjects, etc., all this information will get stored into your DBMS tables. And the advantage of this DBMS is that as and when required, you can retrieve the data from the DBMS, you can update it, delete it as per your convenience. When you will be doing data analytics, or data analysis, most of the time what happens is that you don't uh, work on this data which is there in the DBMS or RDBMS, because this is something which is in production. If accidentally you make any changes here, it can cause your whole application to crash, right? Your whole application may get crash. So because of which, what we do is that we ask the DBA, that is database administrator, you will ask that person to fetch the required data, and he or she will run some SQL queries. Okay. And through those SQL query, yeah, I think somebody want to say something. Am I audible?
No. Please go ahead.
Participants?
No issue. Please go ahead.
Okay. Yeah. So the DBA person will run some SQL queries, and it will save the result in the form of some file. This file could be either a .csv file. I will discuss about this one in a while, or it could be your .xls file, that is Excel file, or there are many other formats, JSON, etc. So this data will be later provided to the data analytics team. And here comes our next topic into picture, which is Pandas. So with the help of Pandas library, whatever data that have been sent to you by the DBA team, you can read the data from those respective files. I just discussed about the various types of files: CSV, XLS, JSON, XML, and many more. So you can read those files, you can read the data from these files, and then you will create something called as data frame objects. Now, what is this data frame? You can think of data frame as a table-like structure. Just in the previous session, you might have seen how to create a table, how to there will be column rows and columns, etc. Right? So data frame is equivalent structure, and whatever data you are reading from these files, from any of these files, it will get stored into this data frame object. Now this, just like NumPy that we have seen, this data frame comes with n number of functionalities using which we can perform the data analysis or data analytics on our data, through which you will be able to create insights. So that is the use of Pandas. So Pandas is basically a Python library which is used for the data analysis and data manipulation purpose. And one more fact is that this Pandas library it has got dependencies on NumPy. It is built on the top of NumPy. There are a few more libraries such as Matplotlib, Seaborn, which are used for the data visualization. They are also built on the top of NumPy. So you can understand the importance of NumPy. If in your system you are directly trying to install Pandas, okay, it won't get installed. It will show you an error. It will say that the NumPy is not there. So first you will have to install the NumPy and then go with the installation of Pandas. But now, since many of you might have followed what I have advised, is to install Anaconda. Okay, so in that case, you don't need to install any of these packages. This Anaconda will automatically install Python, Jupyter Notebook, which is an editor, and all those packages which are required for data analysis, data manipulation, and data visualization. So, let me start the coding. Okay, so just give me a minute. The very first thing that you have to write here is the import statement. Import Pandas as PD. Something we have already seen in case of NumPy, right? So from now onwards, I'm going to use PD for shortcut. Next is that how we can create the data frame object. Let's see, using some inbuilt Python data structure, can we build the data frame objects? And later on, I will show you different types of files, be it JSON, CSV, Excel, how to read the data from those files. Later on, okay, let me quickly explain you the. So initially, we will see how to create a data frame. So data frame creation is concerned, we will first use Python-based data structures or connections like list, dictionaries, etc. Then I will show you how using files we can create a data frame. Once this is done, I will explain you some summary functions related to data frame. So that will give you some high level information about the data which is present in the data frame. Followed by that, uh, I will discuss about some. There is something called as series in data frame, which is nothing but a column in your table. So there are some, again, some functions related to series, and you will find out here that the series are nothing but internal sort of NumPy array. So most of the functions that we have seen in case of NumPy, same thing you will also see here in case of series. And then we will go with the indexing. Now, as we have seen earlier, here indexing will be a little bit different, but the concept of indexing and index lasting is still there. Sorry. So let's start with the coding, and what kind of data frame you would like to see here? What information you want me to put there? Most of you are students, I guess. Is there any working profession? Let's say that I have to save the student data. Okay. Now, what kind of information you would like to save when it comes to student data? Yes. Okay. So let's say we will start with the very basic information, which is name of the student, right? So I'm going to create a list called names, and we will have a list of names. So let me check who is there in our session, and I will try to uh, add the similar. I'm not able to see the list of participants as of now, so I will just put some random name there. So let's say Nile, Alea, Mira. So let's say these are the names of the students, and here I have the list of the student names. So I want to create a data frame which is there in the Pandas. So df equals to, we usually use this notation of df. If you have got multiple data frame, maybe you can use df student, okay, student, maybe df faculty, like that, right? So let's create a data frame student is equals to, now how to create the data frame is when we have to use this pandas pd dot data frame, and here I will pass the names, right? If I execute this, there is no error. It means that everything seems okay. And now let me check the content of this data frame. So I'm going to print this data frame. Okay, sorry, it says df students, right? So my bad. So df students. So you can see that we have got 3 rows of students. Each one of them is having index starting from 0, 1, 2, right? And as far as the column is concerned, the column name is 0, right? Which is quite absurd, right? So maybe we will have to work on it, how we can set the column name. Apart from that, in real life scenario, what you will observe is that as far as the structured data is concerned, it is always two-dimensional, right? There will be number of rows and columns. So in such cases, maybe what I will do, I'm going to construct another example. See. So now instead of names, I will say student. Okay, students. This is going to be a 2D list. So I will have to use these double brackets, and here the first student will be relay. Okay, done. So for Nila, I will also add some additional information such as CGPA, let's say 8.8, and then the branch name, let's say computer science, CG. Just for the sake of better readability, I'm putting this different records in another line. Let's say 8.9. Branches, let's say ETRX, and then finally another student whose branches, let's say mechanical. Okay, so we have constructed a 2D list. Now let's see how we can create a data frame out of it. And I'm going to repeat some of the code that we have used earlier. So let me quickly copy this code and use it here. So df student, now instead of names, I'm going to pass the student. It should be actually students, right? Because there are multiple records. So, I mean, even if I write just student, it doesn't matter. There won't be any error, but it's a good practice to follow such kind of naming convention. Okay, students, and then I wish to print it. Here we go. So now you have a data frame where there are 3 rows and 3 columns. Again, what we see here is that we are missing the column names again, right? So how we can set the column names? Well, for that, there is one more parameter here that we will have to add, and it goes by columns. Columns equals to, here we have to pass the list of string, and that string will be nothing but the name of the column. So I will say name of the student, name of the student, followed by CGPA, and then branch, right? Branch in which they are studying. If I execute this code now, you can see that I have the appropriate column names given to my data frame. Well, what you can do is, I mean, we have just constructed a data frame using a list. We can use dictionary also for the construction of this data frame. So I'm gonna quickly demonstrate another example where we will use the list. So sorry, a dictionary. So student dict equals to, so we will have name as key, right? And to this I'm going to pass the names of the student in the form of list. So maybe I can use the previous code, this one, right? Okay, it's done. Next one is what we want. We want the CGPAs, right? This CGPA. And let me add some random values here now. So and then the branch names, right? Branch. I'll just put some random name here just to save some time to see. Okay, so we have created a dictionary. Now let's build a data frame out of it. So df equals to pd dot data frame, and just pass this student dictionary, and you can see that we have constructed a dictionary. The keys of the dictionary are used as column names, and whatever are the values mentioned within the list, which are nothing but the value inside that dictionary, are used as they are used in the rows, right? So this is how we can construct data frame from list and data and dictionary like structure. But in most of the cases, you are going to read the data from file into a data frame. So I'm going to show you one example. df equals to okay, read has to be pd dot read. We can see that there are so many read related functions. Read CSV, read Excel, read HDF, which is Hadoop data, read JSON file, read SQL. We can also send a query from here, and whatever SQL query, whatever is the result of the SQL query, that result will be stored in the form of data frame, and it's XML is also there. So I'm going to show you the example of JSON. Have you heard of JSON? Well, I'm not writing this. Okay, so this is the your pandas object, and this is the function name, read JSON, and here I am passing the name of a file. I already have this file in my folder. Let me show you its content if I can. Just a moment. So, here we go. If you observe this file carefully, you can see that it is nothing but a dictionary like structure. So this is a dictionary, right? We have key, value, another key, another value, and so on. So this is one dictionary. Then I have what? I have a list of dictionaries, right? This is a list. Within this list, I have got multiple dictionaries. Got it? Now, what is this? This particular structure is called as JSON. Now, what is this JSON? JSON stands for JavaScript Object Notation. Nowadays, it is one of the most common data format which is used to transfer the data on the server. So, for example, maybe you are using applications like Facebook, WhatsApp, okay, Spotify, anything, or even your banking application. So maybe you will log in first, right? So there you are providing your username and password, right? So this information is converted in the form of JSON, and then it is sent to the server machine. If you are writing a tweet or a comment or a review related to a product, so again that information will also sent across the server in the form of JSON. Earlier, XML was quite extensively used for such purposes, but nowadays JSON is the primary choice of the developers. So you may also get data in the form of JSON, and here I'm showing you that you can read the data from a JSON file into a data frame object. So you can see that in this file we have 4 columns: sepal length width, petal length width, and fifth column is the species of that flower. So it's a flower related data. Another example I would like to show you here is related to the Excel file. So read Excel is the function name, and again you will have to pass the name of the file. Let me quickly check the name of that file because I don't remember that file name. Okay, it is emp.data xls. So you can see that this is my emp.xls file. I have got 2 sheets here, data 1 and data 2 sheets, right? So in the first sheet we are starting with the Brandon. Maybe this is employee or customer related file which store the information. Second one start with the Parker. Okay. So if I want to read this file, I will write it like this: emp data.xlx, and then okay, let's execute this. We will see what happens. So you can see that by default the first sheet have been read by this data frame into this data frame. What if you want to read the data from the next sheet? Well, there is another parameter called sheet name. By default the sheet name parameter will have the value of 0, which is nothing but the first sheet from your Excel file. Here I'm putting 1. So let's see if it is fetching the data from the second sheet, which start with the Parker. So you can see that now it is having the data from the second sheet. If I put it back to 0, it is showing the data that is starting with the Brandon from the first sheet. Fine. Now last one example, and CSV. In most of the cases, you will have a data in the form of CSV. It is also called as plain text file. So there are plain text file, CSV. Okay. Now what is this CSV? CSV means comma separated values. So let me show you the structure of one such file here. Here is that file, nba.csv. Maybe it will show you here. Just a minute. Yeah, here we go. So this is my CSV file, and you can see that here the values are separated by commas. The first row is nothing but the names of the columns. From second row onwards, we have the data. So each value is separated by column. So it is, so as I was discussing, you will, being a data analytics engineer or a data analyst, you will not be working on the DBA. I mean, no doubt having the knowledge of SQL and DBMS is very important, because it varies from company to company. In some company, maybe there will be a DBA, but being a data analyst, you are maybe it is your responsibility to fetch the data from that DBMS. So in that case, you will have to write the queries. In big company, I mean, this is the case mostly case where I mean, if you are working in the startup like companies, but if you are working in a bigger organization, in that case, you will have separate people whose job role is defined, and they perform a particular task. So there will be a dedicated DBA person who will take care of those queries and all that. So, all I was saying is that the DBA will fetch the data by writing appropriate select query, and then it will put the result of that data into such type of CSV file. So in most cases, you will find CSV file data. So I'm gonna read that file here. It is nba.csv, right? And here we go. So here is the data of NBA. Now NBA is it's a volleyball tournament in USA, and here we have the data related to it. It contains the information such as name, that is the name of the player, team, name of the team, then number of a player, its position. So in basketball, there are in that basketball field there are different positions of the player. So their short forms are mentioned such as PG, SF, etc. Age, height, weight, college name, and salary. So these students are basically recruited from the college systems, right? So that is all about the data frame and pandas in nutshell. Do you have any questions, any doubts? Please let me know. Otherwise, we will move to the next part, which is I'm not able to. Mm, just give me a moment. Let me share that link of the quiz. Sir, my Zoom controls are freezed, so I'm not able to share the link via Zoom. Is it possible for you to share it amongst the students?
Yes, yes, I will share it.
Yeah, please. Thank you.
Dr. Neelan, now you try.
Okay. No, sir. Maybe I will have to restart my system. Then I will be able to have this functionality, because actually I'm working on a dual monitor setup. And,
Okay.
and yeah, and in the middle of session, I have just transfer my projection to only one monitor. So maybe because of that, Zoom got confused and it has freeze that control for me. I mean, this is the bug from the Zoom, which I encounter sometimes. So shall I restart in 2 minutes?
Yes, yes.
Yeah, yeah. So participants, please give me 2 minutes. I will join quickly. Yeah, so now let me share that link with you. Yeah, here we go. So students, I have entered the link in the chat for the quiz. Please go through it and we will start with the remaining part of the pandas. Okay, so I hope that you have completed that quiz. Let me switch to screen. Data source. Just a moment, I will share the screen now. So here we go. So we have just seen how to create pandas data frame and pandas data frame from list, dictionary, then JSON file, Excel file, and CSV file. As far as this NBA data is concerned, further we will explore further functionalities of pandas and data frame using this data set. So let's start with some interesting, I call them summary functions or summary attributes. One of them is, now df is my data frame, right, which holds the data of this. We just want to have a glimpse of the data. You can use this df.head function. Maybe if I type this code now, I may get an error because I have just restarted my system, and this whatever I have executed earlier before restarting my system, it's all gone, right? So I will have to import this pandas again, and if I come back again here, I will have to read the CSV file, and now we can see that this df.head is working properly. Just give me a moment, let me hide this header so that we have enough space here. Now it's better. So you can see that, so sometimes you may have output of your cell ranging in multiple lines. Maybe it is no longer required once you have analyzed it. So what you can do is you can just double click in this region of the output, double click, and it will collapse that particular output. Again, if you want to check that one, again go here and click once. It will open that output again. Okay, so I was talking about the head function. So this head function will display the first 5 rows from your data, and this is enough to understand what are the columns are there and what kind of values are there, right? So obviously you will not get the detailed idea about all the millions of rows, but it's a good, I mean, it will give you the brief idea that okay, name is there, so this kind of names are there, some team name are there, etc., right? And by default it shows 5 rows. If you want to explicitly see more rows, then in that case you will have to explicitly mention some values like 10, 12, 15, something like that. So in that case, it will show you those many number of rows. Now, these are the first 5 or first 10 rows from your data frame. If you want to see the bottom one, in that case, we have df.tail function. and it will show you again last 5 records. You may pass another integer value here, a parameter here, and accordingly it will show those many number of last rows. Fine. If you want to check the data type of this df variable, you can use the type function, and you can see that it is from the pandas libraries. There is a data frame class. So this is a type of data frame, right? Let me add lots of rows here. So I will not have to. Okay, now let me show you some quick summary. So df dot shape. I hope you remember this shape attribute. We had already discussed this in the morning, right? In NumPy. So see, in a way, this data frame is nothing but a two-dimensional NumPy, right? It's a tabular structure, correct? So, and since this pandas is built on the top of NumPy, with all the NumPy related functionalities are also available in pandas. So shape is one of them. Then if you just want to have a look at what are the columns that are there, then you can type df dot columns. So that will give you the list of the columns. Then you have there df dot columns. What else we have? Df dot shape over here, df dot columns. Yeah, df dot info. Df dot info. So maybe you have seen similar kind of output in the SQL session, where if you have once you have constructed the table, you write describe table query, right? So that gives you the names of the columns along with their data types and some other information. Similar kind of result can be achieved through pandas, and for this we use this info function, df.info function. So it gives you the list of columns, how many non-null values are there in this data set. So for example, in total we have got 458 entries in our data set, right? And most of the columns have 457 non-null values. It means that in almost all of the column there is one null value, and as far as the college is concerned, there are about around hundreds of values which are null, right? And finally, data type of each of column mentioned in this last column. Types such as name, team, which are basically text based, right? So these are string values. They have the data type of object, whereas the numeric value will have the data type of float or integer. And finally, it is showing you how much memory is used by this particular data set. Okay, so that is all about the info. Now then there is df.describe. So output of this one is quite interesting. You can see that not all the columns from your data set. When I'm saying data set, I'm talking about that nba.csv file, right? So what we see here is that not all the columns from the data set are included in the output. Only those columns who are numeric, which are numeric in nature, such as number, age, weight, salary, right? So we have got the count of each of this column, average value, standard deviation, minimum value, maximum value, 25th percentile, 50th percentile, and 75th percentile. So basically gives you a statistical summary of your data. Fine. Now let's move to the next topic. So we are done with what I can say, this summary. Okay, summary related functionalities. Now I want to talk about something called as series in data frame. A typical data frame consists of n number of columns, right? And if you try to access each of the column, that column is nothing but it is of the type of series in Pandas. Let me show you how. First of all, let's see how we can access the values inside a particular column. So for this, we use the data frame object, square bracket, single quotes or double quotes, and then name of the column. Make sure that you are writing the same spelling, okay, because this is case sensitive. So you can see that here we have got the all the players age. And if I try to check the data type of this particular one, okay, so TYPE. So you can see that it is showing that this particular information or value that we are displaying is of the type of series. So your data frame consists of multiple series. There is one more way to access the values in series is instead of using square bracket and then double quotes notation, you can use the dot operator and just mention the name of that particular column. So in this way, you can have access to value inside any column. df dot, let's say salary. Okay. Not only that, you can also access multiple columns at a time. So let's say I have got 10 columns in my given data set, but maybe I want to find out the names of the players and their salary, right? So maybe you are one right name, comma, salary. Now let's check the output. Here you can see that I'm getting an error. Why I'm getting an error? Check the description of this error. Key error, name and salary. Now, students, what kind of output will be there? Just a moment. See, if I'm saying that I want to show the data, which includes name, and then I also have salary, right? So name values will be there and salary values will be there. What kind of data is this? Is it a one-dimensional data or two-dimensional data? See, if I just print the name values, okay, dimensional data, right? I can accommodate this kind of information in a single array. But if I have two columns like this and number of rows, then it becomes a 2D data, correct? This is your tabular data, 2D, two-dimensional data. So if you want to access 2D data in your data frame, then obviously you will have to use two brackets notation, which is commonly used for 2D arrays. And now you can see that you are able to access any of the column. I hope you have understood this thing. And in this way, I can select column of my interest and get the values printed, or I can have access to those values. What if I want to create a new column in my data frame. Yeah. Any questions? Any doubt? Fine. All I'm going to do is, why it is not typing? DF. Okay, just a moment. Okay. Yeah. Fine. So DF, just mention the name of column. By the way, you can, as I had mentioned earlier, you can either use single pair of single quotes or pair of double quotes. So I will write game equals to basketball. Okay. So before I execute this particular code, let me just give you the glimpse of this existing data set. So we have these many columns, and now after executing this game equals to basketball, I'm gonna again print df dot head, and you can see that a new column have been added here, and for each of the row the value is initialized with basketball because we have done this initialization. So in this way you can add a new column into your data frame object. Now this is a hard-coded value, right? It's a static value that I'm assigning here. All of them are having the same value, game equals to basketball. But there could be some columns which may have different values for each of the rows. For example, salary, for example, height, weight, etc. Right? So maybe you want to construct a new column and you want to come up with a different value for each of the player. So to illustrate that example, let's consider this weight column. Now at present we can see that it is made, this weight is measured in pounds, right? So maybe I want to create a new column called weight in kgs. Okay. Anybody is having idea about how to convert uh, pounds into kg? Can anyone please help me with the formula? Yes. Let's try it online. I guess it is half of the pound. So weight in pound is basically double of weight in kg. But still, let me check it. Kg to pounds. Yeah, it is 2.2, right? So this is the factor, and if we have the pound here, 1 pound equals to 0.4. So I will use this value. Okay. 0.45 into 0.45. So what I'm doing here is that first I'm trying to create a new column called weight underscore kg that will contain the player's weight in kg, and how I'm going to compute it by using the existing column which is weight multiplying it with this particular constant value as I have shown you in the formula. And once this is done, I would like to quickly see the content of my data frame. Fine. So you can see that we have created a new column called weight kg, and based on, obviously, I mean, it is possible that some person some player may have similar weight, but in most cases you will see that a different value is there inside this. Right. Now let's say I want to create one more column called tax, and let's say that I mean we have got a column called salary, right? So can you please help me? Can you please write a single line of code to create a tax column, and that tax will be the 10% of this salary. Please, I mean you have the clue already available here in this cell, in the 20th, 21st cell. See, I wanted to have these sessions interactive, okay? Otherwise, it is going to be monotonous session. Only I'm going to talk and I'm going to write the code, right? So in between, I'm going to give you some uh, challenges, right? Based on whatever you have done until now. Okay, now let me write the code for this. Copy this one. And let's write fresh code. EF tax equals to DF salary. That is 10%. That means 0.1. DF dot here. So a new column called tax is added here. Got it? So that is how you can manipulate the data in Pandas. And if you check now, earlier the shape was quite different. Now we have df dot shape. So you can see that now we have got 12 columns in total. Earlier there were 9, I guess. Fine. Now we move to the next topic, which is indexing. Something you might have already used in list and numpy. But apart, similar sort of indexing is there. But apart from that, there is something called as ilock and lock function, using which we can do the indexing. So I will also explain you this in a while. Before that, now is the time to for our quiz 2. So let me quickly share that link with you. And before I do so, let me just explain you one more functionality. is now see that here we have quite huge number of columns here, right? And and if you have 20 or 30 number of columns, then in that case you will have to scroll it horizontally, right? Now that becomes sometimes quite irritating. So what I prefer is just to write df dot t, sorry, df dot df dot t is there. df dot t. So this will print the transpose. Okay, so this is printing the transpose of your data frame. Now your rows are in your columns and your columns are now rows. So you just have to scroll the vertically in looking at this first column and second column, you will get an idea that what kind of data is there in your data set. You can also write code like this. I mean, maybe we earlier had df dot head, right? Df dot head. So you can again apply the transpose to it, and you can get the same output. Only here the number of columns are restricted to the 5, count of 5. Fine. So let me quickly share the link of the next piece, which is here. Please open the Google form and answer the quiz questions. After that, we will have a 2-minute break, and then we will switch to the next topic, which is of indexing. Students, I will be back in a minute. Okay, students, I'm back. Let's continue with the next example. Here we go. So as I was telling you, there are two ways to when it comes to indexing in a data frame. First one is called as ILOC, which is which is integer based indexing. Then another one is lock, which is label based indexing. So let's start with the first one, which is ILOC. So let's say if I write df of 0, what happens here? I'm getting an error, right? Earlier, in case of numpy array or list, this was not the case. So because we need something called as .iloc function, .iloc. Here you mention the index, integer index, right? So you can see that at the 0th location, whatever data I have, I'm getting populated it here using this iloc function. So this particular one, right? Avery Bradley. So a record of, I mean, this person is at the 0th index, right? Let me show you the output again without transpose. So you can see that this is the person whose record is at the first location, which is at the 0th location. Its corresponding index value is 0. So hence, by using this iloc function, I'm able to fetch its record. So accordingly, you can get the record of your interest. Let's say I want the record of players having index, let's say 100 to 110. So this is how we write. So here we are talking about the row index. This is the row index. Notation is same, only there is an addition of iloc keyword. What if I'm interested now? In this case, it is printing columns of, I mean, all the columns for these 10 players, right? Let's say I'm interested in only few columns, maybe just height, weight, right, and player's name. So how that can be achieved? So this is the thing, and let's say comma. Let's say I'm interested in first 3 columns, or maybe first 5 columns. So I will write 0:5. So this is responsible. This is starting row index and ending row index. Next part is basically starting column index, ending column index. That is how it works. What if I want to select some some columns such as maybe name, age, height, weight, and then salary. So you can see that I have skipped few columns, and with this rotation I can have access to only consecutive columns, right? So how to overcome this? Well, in this case, what we can do is I can write like this name. So here I'm getting names of only those 10 players. Maybe I'm interested in few more information, so I will use this notation of 2-dimensional array, and let's say age, power, and their salary. So you can see that these 3 columns are not consecutive, right? If you check the original data set, we have name, age, and their salary, right? So in this way you can access records of your interest. Okay, so that was all about the iLock. Now if iLock is there, I mean, you can see that iLock is sufficient enough to get the desired results from or desired section of the data from our given data set. Then what is the use of lock function? The lock is used when you want to do, when you have a label based indexing. Now what is label based indexing? Let me explain you quickly. For this okay, for the moment I'm skipping that particular part. Maybe at the end of this session I will try to cover it, because I have to cover a few more topics there. Okay, so iLock is done. Next topic is mass indexing is done. Let me check. Okay, good. Now this is something we have already seen by the in NumPy. So let's say there is a column called age, or maybe salary. So if I want to calculate, if I want to find out the minimum salary, maximum salary, minimum age, maximum age, we can use the same functions which we have used in NumPy. So this will give you the minimum age. Then this will give you the highest value in the age column. This will give you the mean, and other functions such as standard deviation, variance. All those functions again are applicable. Now one thing to note down here is that these functions can be applied only on series data. What is series data? If you remember, series is nothing but a single column in your data frame. So age is just a series. It is a one-dimensional data, right? So we have seen in NumPy also, we can apply these functions to NumPy arrays. Same thing we are doing here. Nothing new. Now that so standard deviation and variance, I'm not writing them here, but I hope you have understood it. Okay, let me quickly write it just for your reference, because you are going, because this will be a reference point for you to practice, right? So I should not skip anything. Standard and variance. Now let's say I have this data frame. There are about 500 records, and I want to have the information about what are the different teams which have participated in this uh, tournament. Now I'm slowly moving towards the analytics part, because through this analysis maybe you would like to draw some information, right? So I want to know how many teams are there, what are the teams are there, right? So in that case I can write df teams dot unique. I guess it's a function. No, it's not a function. It is a new just a moment. I think I'm missing something. In df teams dot unique. Everything seems perfect. Maybe team name is wrong. Let me check. Okay, I have it's team there in the column, and I have written teams. So you have to be very careful, as I had mentioned earlier, because these things are case sensitive. Yeah, here we go. And so it is giving me an array that contains the list of all the colleges. Now you can see that I don't have a repetition of college names as it was the case with this earlier output, right? Here I can see the repeated entries. Here I can see only unique entries. So maybe what I can do, I mean, this will give me the list of college, and if I want to know their total count, I can use this len function, right? That will give me the college counts. Or now this is another function, value counts. This is quite interesting one. When you do univariate analysis mostly, I will tell you what is univariate analysis. So at that time, this function comes quite handy. So in this case, in case of unique function, it just gives you the names of unique values. Here, it not only gives you the list of unique values, but also the number of occurrences of that particular value. That is nothing but the frequency of that particular value. So in this way, you are able to understand that in each team, how many members are there in this from this particular data set. So in most of the cases, you can say 15 is a quite standard number. If you want to have a look at the distribution of age, so you can also check that one, value counts. So you can see that there are about 47 players who have age 24, 45 players whose age is 25, and so on. And you can see that there are a very small number of players who are quite aged, who are quite older, or who are quite young, right? So from this, you can draw the conclusion. Okay, if I put 10 as my threshold value, right? So I can see that and this is quite true in case of sports industry, right? If you grow older, I mean, you actually get retired early, right? You will not be playing the games till your 50s or 60s, right? So, well, this is a well-known fact. But if you have a data set which is, I mean, which is not common like as this one, right? So, in that case, by studying this data distribution, you can draw some conclusion. Okay, so that was all about the unique values and value counts. Now let's move to the another topic where I would like to discuss about how to handle null values, because that is one of the very important step when it comes to data analysis and analytics. And null values. Now see what happens is that uh, now why there are null values in the first place in your data set. There could be n number of reasons. Reason number one is maybe due to human error. Many times what happens is that you have been asked to enter some registration form online, right? And sometimes there are so many fields, right? And maybe you decided, okay, I don't want to fill this field. I don't want to enter the data for this, but maybe some set of fields, right? So in that case, what will happen? Whenever that data will go into your database, right? So while entering your data into the database table, those fields will have null values, right? So this could be the reason. So so human nature, because of human nature, you can see that some null values are there, right? Or maybe some data entry operator is entering the data and by mistake he or she left that some particular fields empty. Even in that case, null values will be there in your data set. So human error is one point to be discussed. Sometime, as I had mentioned, the DBA, right, database administrator, he will give you a CSV file as we have discussed, right? But that CSV file is not directly generated. Maybe in the database, there are multiple tables, right? Table 1, table 2, table 3, right? And maybe he's fetching the data from all these tables, not all the columns, but some of the columns. And this is called as something called as join operation, right? So in that case, the result which get produced, it often have large amount of null values, right? So this could be the another second reason for having the null values. So how to treat these null values? Well, first remedy for treating this null value is that remove this null value records. What I mean to say, suppose I had fill up. Sorry, my bad. Suppose I have a data set like this. There are thousands of rows. Okay, and maybe in this particular row there is a null value. Okay, so you can remove this null. You can remove this whole record from your data set. Okay, and thereby you will not have any null value in your data set. But sometimes what happens is that, I mean, if there is just a single record or maybe some handful records are there which contains null value, in that case it is okay to delete these rows. But if you go on doing this for a large amount of data, in that case, maybe you have a very small data set, maybe of 1,000 rows, right? And out of them about 700 rows have the null values. In that case, what you will do? Okay, or maybe you have got 200 300 rows which have the null values. So that is a major chunk of your data set, and maybe for some columns there are null values, but in the rest of the columns there is quite important data which is lying there, which is helping you to to find out quite interesting pattern from the data set, right? So in that case, it is advised not to delete the data, right? So how we can overcome this problem? Well, for that, let me explain you the types of data first. So data can be divided into a numerical data. Another category is categorical data. Within numerical, you have again two categories uh, such as discrete values, and then you have continuous value. I will explain you what is this discrete and continuous. Continuous. Okay. As far as categorical are concerned, we have got here again two categories. First one is called as nominal. The second one is called as ordinal. So in case of discrete value, example includes such as number of students who have attended this particular workshop. Okay, so that is going to be a whole number, right? You will not have 30.5 value, right? You will have 30, 35, 20, 25, something like that. Number of buildings, okay, number of buildings, sales count. So all these are examples of discrete numerical values. Then you have got continuous values, which are nothing but fractional values such as height, weight, salary, right? Provided that salary is a float number, right? So these are examples of continuous data. In case of nominal, as far as categorical is concerned, it is mostly in the form of non-numeric form, mostly in the form of text data. And nominal means only name is there, such as name of the cities, name of the countries, okay, maybe gender, okay. So city name, gender we have male and female, right? So that's the only text information. There is no numeric information. In case of ordinal, let's say ratings. Maybe you have watched a particular show and you can rate that particular show on some platform. So good, bad, average, poor, etc. Right? So this could be the rating values, or maybe shirt sizes, right? T-shirt sizes. So you will have sizes like small, medium, large, extra large. So you can see that this is not again non-numeric data, but there is an order within this data, right? So small is less than medium, medium is less than large, and so on, right? So hence it is called as ordinal data. Now why I'm giving you the brief detailed idea about what are the different types of data, because based on what kind of data you have, right, in your data set, I mean, as far as the missing values are concerned, based on that you will have a different strategy. For example, let's say I have a numeric column, let's say age, okay, or maybe salary, right? So maybe you have a data set, and in that data set, as we have considered, there are about 500 players data, right? So maybe there is a column 1, okay, and it has got 500 entries, right? Out of this 500, let's say only 100 entries are valid and remaining 400 entries are null. Fine. So this percentage of null value is more than 50%, right? So this is a thumb rule. I mean, it's not a standard formula. So in that case, you can delete this particular column because you don't have the sufficient information related to that particular column. But in case if this, let's say there is another column C2, and there out of 500 entries, let's say you have only 100 columns are having null value, the rest of the 400 have some data in it, right? So this percentage of null value is less than 50%, right? So in that case, what is to be done? So I'm going to discuss those strategies now here. Let's talk about the age. Let's say this particular column is of age. So what I can do is I can, wherever there are null values in this column, I can replace them with the mean value of this age. Understood? Now, why we are taking mean? Because mean is also mean, median, mode. They are called as central tendency. Just by having a look at those values, you will get a rough idea about that group. Okay, if the mean age is 25, it means that most of the people in that group are having the age equals to 25 or nearby 25, maybe in the range of 20 to 30, like that, right? So by filling those null values with the average value of age, that average value is not the exact value of that particular player, but in most cases it will be very close to the actual value of that particular person, right? So we take the average. Now there is one downside with the average. Now what happens is that, let's say we have a country, okay, and there are, let's say, maybe country or maybe a group of people, okay, group of people, just 5 people are there for the sake of example. So let's say their salary is 1 lakh, 2 lakh, 1 lakh, again 2 lakh, and plus 3 lakh. Okay, I want to find out their average. Can you help me with the calculation of this mean salary? 339 divided by 5. 9 divided by 5. Let me make this 2. Okay, this will become 10. Okay, that comes out to be 2. So the average salary of this group is 2 lakhs, let's say. Fine. So this is the average value, and you can see that majority of the values are either 2 or very near to 2, right? Let's consider another group of people where they have salaries like 1 plus 2 plus 3 plus 2 plus 10 lakh. So this particular person is a CEO, right? So maybe he's having a higher salary. So in that case, if you try to calculate the average value, what will be the average? 3, 6, 8, 8 plus 10 is 28, 5 which comes out to be 5.6. Now you can see that just by introducing one extreme value, your mean have deflected a lot, right? It has changed a lot. So this is the drawback of calculating the average. It will always have, it will introduce a bias if you have added some extra, if you have some extreme values in your data set. So to overcome this, we can, instead of mean, we can go for the something called as median. So let me go back to the previous data. So 1, 2, 2, 2, 3. Okay. In first group 1, we had 1, 2, 2, 2, 3. That was the salary. In group 2, we had salaries like 1, 2, 3, 2, 10. Okay. 1, 2, 2, 3, and 10. Right. Now, in this case, what happens is that if you want to calculate the median, there is something called as median. You first arrange the values in a sorted manner, in ascending manner, okay, and then you find out the middle value. In this case, it is 2, right? Here again, we have the median is 2. So you can see that in this way, now your extreme value is not affecting the central value of your that particular group. So maybe you have got, maybe you want to replace the basic value in age, salary, or any other numeric value. You can go for either average, that is mean, or median, right? So based on the problem at the hand, you can take the decision. Well, that was for the numerical columns. Now let's say if you have a categorical column, right? For example, we have what do we have? A position. Okay, position is one such column in our data set. There are multiple types of position. C is there, PG is there, and many more in our data set. Let's say there are about 50 such rows where this position column is having null values. Now, how to deal with this particular problem? Because we cannot take the average, right? We cannot take the median of this categorical value, right? Because to calculate these things, we need numbers. So in that case, you can go for the mode. Now, what is mode? Mode is the most frequently occurring value in that particular column. So let's say that PG is occurring for most of the number of times in this particular column. So if there are any null values, we will replace them with the value of PG. Got it? So enough of theory. Now let's try to implement the code for this. For example, first of all, we will have to find out if there are any null values. So is df dot is null is the function using which you will get an idea. As the name suggests, is null. So it is asking question: is there a null value in each of the cell? So answer will be in the form of true or false. Obviously, you are not going to check each and every cell here, right? So what I'm going to do is I will write df dot is null dot sum. So you can see that here we have each column name, and against each column name how many number of null values are there. So we can see that in most of the cases there are null values, okay, a single null values. But as far as college, salary, and tax is concerned, we have a considerable amount of null values. So we will try to fix this. So how we can do it? Don't we have age? Where is it? Okay, here we got it. So what I will do, I can first calculate the average salary. So AVG sal is the value that I'm going to compute. DF salary dot min AVG sal. Okay. So this is the average salary for our data set. Okay. Now I want to replace it, right? So I will write df dot fill in it. I think I will have to mention the salary column, right? Salary dot fill in it. Methods, method, okay, access is there. Okay, fine. So the first parameter will be this value with which I want to replace those null values. So let me copy this variable name as it contains the calculated mean salary. Next one is, next parameter is access. Now I want to perform this operation along the column, right, on the salary column. So I will write access equals to 0. Okay. And to make these changes permanent, in place equals to true. So remember, there are some functions in data frame. Suppose if you are updating or deleting the values from the data frame, so that such kind of functions require this in place equals to true value as a parameter. So that will make those changes permanent in place in your given data set. Fine. So let me execute this. Let's see if it works. Now it seems that there is no error, right? But in data analytics, you must cross verify the result, right? Now, how I can cross verify? All I can do is I can again execute this code, okay, here in the next cell, and now I can see that as far as the salary column is concerned, there are 0 null values. It means that it's working, right? It has worked. So in this way, you can go ahead and delete the, fill the null values with some appropriate values. If there is any column, let's say which have more than 50%, maybe more than 250 null values, then in that case, you can straight away delete that particular column. Let's say, for example, just for the sake of example, let's say I want to delete this college because maybe it is having 300 null values. So I can write df dot drop function. The column name that I want to delete is college, right? Then I will have to mention the axis. Again, I want to perform this operation along the column. Remember, if you accidentally mention axis equals to 1, then all the rows wherever there is a college value, all those rows will get deleted. So one has to be very careful. And in place equals to true. So maybe this college is quite important field considering the data analytics. I would like to go delete that game column because it contains the same value, which is basketball. Okay. And after that, I'm going to print the output. Okay, it seems that something is wrong. Let me check the definition of this. Now, this is quite common thing. Maybe whenever you do the data analysis and you don't remember the function details, so just go there and check the labels. Okay, labels in place is there. Single list. Maybe I have to include this as a list. Oh, still not working. Okay. How it can be done? df dot drop, that is correct. Name of the column, axis equals to 0, in place equals to true. Yeah, everything looks correct. Why it is giving me error? Let me check what is wrong here. Okay, my bad. Sorry, it has to be. Sorry. So one is for column, I guess. So let me check the documentation again. Axis. Okay, one is for the columns. Sorry, my bad. One is for the columns and 0 is for the row. So now you can see that game column is no more there, right? Now with this, we come to the last section, which is called as filtering. It will not take more than 2 to 3 minutes. Filters. So earlier, whenever you type head, you get first 5 or n number of rows or maybe by using a while loop, you can print all the content, right? Something like that. Or by using iloc, you can print specific range of indexes, right? But what if I want to get the list of players based on based on some conditions like maybe age is ranging between this, maybe salary is equals to this, or maybe their team name is this, something like that. So in that case, we use filters. So I will write df age, let's say equals to 25. So in this case, it will give me the list of all the players. Obviously, it is going to be maybe 100 player, or maybe 40, 50 players are there, right? So you can go on add different types of conditions. Maybe salary, the salary is more than, let's say, 1 million. So this is 1,000, 10,000, 1 lakh, 10 lakhs. Sorry, greater than equals to this, right? Or maybe you can, I mean, let's say if you have got two, maybe you want to club two conditions, that is also possible. Maybe I want to, maybe I'm interested in people whose age is in the range of 25, and let me enclose this within brackets. Let's see, another bracket in the range of less than 30. So I'm looking for people who are in the range of 25 to 30. So you can combine two conditions by putting bracket around them. And am I missing something? Just a minute. Okay, this bracket is extra. This bracket is also extra. So here you can see the age of the people in the result is ranging between 25 to 30, right? Neither less than this 25 nor greater than 30. So in this way, you can go on adding multiple conditions here. You can use or also, right? So maybe I want to find out the people whose age is equals to 25 or is equals to 30. Oh, sorry. So only those who have those respective ages, 25, 25, 30, 30, right? Only they will appear here. So with this, we come to the end of Pandas. I hope you have understood it. We have seen earlier how to create data frame in Pandas using list, data structure, and from some files. Then we have seen some summary functions, which gives you the glimpse of the data, right? And then we have seen how to access the data using alloc function, using some column names with that square bracket notation, followed by handling of null values, filters, and all that. And then we have also seen some functions which can be executed just on a series data, such as min, max, mean, or unique values, value counts, etc. If you have got any question or any doubts, please let me know. Okay, let me check the chat window if there are any questions. Okay, no questions there. Okay, fine, sir. As students have no questions,
Yeah.
I'm good to close the session.